Hi, in this scenario, what I'm going to do is talk through a little bit on alarms and dealing with alarms and some procedures that we can think about if we're in a power plant. As well, what we're going to do is spend a few minutes in just looking at some of the control devices on the ship. So where I'm going to go is just look at a system here, main engine seawater system. What this system does is it takes water from the sea and brings it up through a series of valves and filters. In this case, it's going through pump number 2 and makes its way across through a cooler. In this case, it's cooling something, so it's getting a little warmer, cooling something else, again getting a little warmer, and then hot water essentially comes down and most of it gets rejected overboard. Draws in new clean cold water and again circulates through the system. What I'm going to do is I'm going to cause a couple of problems to the system and see what happens. So a good problem that I'm going to create to my system would be to block off flow to the pumps. So I'll do that by closing off these inlet valves. You can see that my pressure is dropping, flow is dropping, and let's see what happens. So I just got one alarm started. You can hear it beeping. And I just got a second alarm that came up. So I'm just going to pause my simulation here so I don't cause too much more grief with my system. There, I'm frozen. Okay, so let's just talk about what I should do first. First thing that I want to do is acknowledge that I have an alarm going on, and I'm going to silence the audible alarm. So the beeping that's going on, what I want to do is stop it. F12 is the key in the simulation lab to silence the alarm. I'll do that now. So silencing as my first course of action is has a couple of reasons. First of all, by silencing the alarm, it allows me to get rid of the noise and allows me to concentrate on the task at hand, which is to try to solve my problem. The other thing that it does is it alerts all of the other workers in the plant that now somebody has acknowledged that there is a problem and will be looking after it. Ultimately, you may not be the person that solves it or troubleshoots it, but you are now in charge, and until you give that responsibility to somebody else, you are in charge of making decisions on this alarm. Good news is that we have a good idea what the problem is. Low pressure coming out of the pump, and we have some blockages, so we're going to be able to solve this alarm. Before we do, let's just take a look at some of the information that we've got in case we didn't know what the problem was. Well, first thing that we see is blinking on the screen. There's a blinking L. L signifies low. If it was blinking H, it would be a high alarm. This time it's low, and what it's telling us is the pressure is low. I have a few other spots where there might be alarms on this page. Temperature or pressure, you can see the A here, meaning there's an alarm associated with them, or down here, the pressure. In this case, it was this pressure that went off. If I go up and click on the alarm box, so in this case 4 I'll look at, what it tells me is a bit more information. So it says for the given pressure, here's what the pressure is, 0.31. Okay, that corresponds to my pressure here. It's blinking red, so telling me there's a problem. And then if I read across, what it gives me are 2 numbers. What these numbers tell me is where does a low alarm trigger and where does a high alarm trigger. So a low alarm triggers at 1. Anywhere below 1, I have a low alarm that's triggered. Anywhere above 3.5, I would get a high alarm triggered. So let's solve the problem and see what happens to my alarm. So I'm going to start the simulation again, and I'm going to open up my valves, and let's see what happens. So pressure should start to get restored. You can see the pressure starting to go back up. What's interesting here is that even though I'm now inside the acceptable range for this pressure between 1 and 3.5, my alarm is still active. So the question is, how do I get rid of that alarm? Well, what I have to do is acknowledge it. So the alarm only goes away by me clicking on it. There's a good reason for why you want to click on it. Number one is that maybe there's a situation where the alarm has happened and you weren't monitoring the system. Well, if it happens to solve itself, so it was some intermittent fault, what you want to know is exactly where was the alarm and what was the problem. So at some point, the pressure out of those pumps was low. And maybe you don't see it or are not part of the immediate diagnosis of that, but you want to be able to know that there was a problem at some point. Acknowledging as well, what you might do as well is start logging that. Depending on what plant you're at, they may have policies around logging alarms. It may be something that you have to note in the logbook depending on the severity of the alarm. And maybe something that if you have a turnover meeting to the next shift of workers, that you note that there were some alarms that came up in a certain area. I also have a 23 alarm that's up, and this alarm, we won't get too much detail into it, but what happened is when the pressure dropped, the first course of action that the plant took, some of the controls behind it, was to start up pump number 1. And so this is just telling me that pump number 1 was started. So was an alarm, but in this case was really more of a notification that was started up. So I can acknowledge it, and I can acknowledge it by clicking right on the alarm in the box. Let's take a look at some other pieces here. So what we also have is a control system that's on this page, and let me just talk through what it is and how it works. So I have this temperature controller here, and what it does is it reads a temperature from over here, so about 22 degrees, and comes to the temperature controller, and the temperature controller makes a decision that seems to come down here and is going to control this device. What this device is down here is it's a valve, and I have two potential exits from the valve. I have an exit going this way, which would be the hot water that could go back into the system and recirculate, or I have a pathway that I can reject overboard. This system, what we're doing is we're running it at about 22 degrees. And since I'm bringing in seawater at 20 degrees, I got to recirculate through a bit of warm water. The pathway here that you see, the black dashed line, what it is a not a pipe as we see as all the solid lines are. What it is would be some sort of signal line. For the most part, let's consider it to be a wire. Okay, so carrying an electrical signal and generally carrying some signal down to the valve. Here's how I can adjust it. If I want to adjust the temperature, so right now it's set to be about 22 degrees. Say I wanted it to be a bit hotter, 25. Well, I could adjust the auto settings, and this valve is going to automatically adjust. So 25, I have to hit enter for it to acknowledge. And what we can see is that my temperature is starting to go up. Well, how does it go up? It goes up by sending more hot water into the system. The controls, as you can see it, is this bottom number. And what that's telling me is what is the valve position. So if I looked at my valve here, I can see that it's about 42% open. About 40% open and continuously changing. And that's going to change depending on how much hot water needs to blend in order to set my desired temperature. And so I can adjust my auto. Say if I set it back to 22, and then what it'll do is it's going to trigger a change to the valve position. I can also manually adjust this valve. So if I click over to the manual mode, then I have full control over the valve anywhere from 0 to 100%, and it will stay at whatever setting I want. So if I wanted it to be 50% open, I could put in 50%, and we can see that if we look down here, my valve is starting to change to get towards 50%. Generally what we want to do is keep these guys in auto unless we're making significant changes. So in order to keep this guy under control, I'm going to keep him at auto at 22. Here's where it's important. So these control systems, I have a similar system to that feed water system when we talk about the boiler itself. So here's my boiler over here on the left hand side, and I have steam that comes off the top and goes off to process. As I consume steam, what it's going to do is it's going to start to drop the water level. So over time, I need to keep replenishing water into this boiler to keep it from drying out. So the system that I have in place is a level controller, which reads the level of the boiler and then adjusts the valve position, the feed water control valve, which acts against the pump. So the further this guy is open, the more water will pour into the boiler and the level will go up. The more closed it is, then the less water can get into the boiler and the level will start to drop. So this guy continuously checks and continuously adjusts this guy. So one of the goals that we're going to work towards over the next few weeks in this course is getting the boiler up and running. In order for us to operate the boiler safely, what we need to be able to do is control level as well as some other things in the boiler. So if we are to address level control, in order to be able to do that, what we have to do is have a couple things. Number one, we need some electricity in order to run our control systems. So a higher priority item for us in terms of starting up the boiler is going to be making sure we have electricity. The other thing that's interesting is, how does this valve actually work? Well, we haven't looked at it in class yet, but these control valves are often pneumatic valves, meaning they run off of compressed air. So in order for us to be able to run this valve, what we need to be able to do is make sure that we have a functional compressed air plant so that we can control our control devices. So for our perspective, before we can start up this boiler, what we need to do is concentrate on getting our control systems available, be able to have electricity, and if we have those things, then we can start to operate our boiler safely, and we'll work towards that goal over the next few weeks. Okay, thanks for listening.